Hello, welcome to lesson 20. In this lesson, we are going to look at minimum deviation by a prism, and then we shall also look at the graph of deviation against the angle of incidence. Let's begin by looking at the minimum deviation by a prism. Minimum deviation occurs when the ray passes through the prism symmetrically, and also when the angle of incidence is equal to the angle of emergence. That is when I1 is equal to I2, which you can call I, and then also when R1 is equal to R2, which you can call R. Let's look at the relation of angle of prism A and minimum deviation, and also refractive index. So considering this ray on a face of the prism at an angle I1, leaving it at an angle I2 to the normal, as shown, we can get the deviation D, because we did this in the previous lesson. So the deviation D is given by D1 plus D2, but we know that D1 is equal to I1 minus R1, and then D2 is also I2 minus R2. So when you substitute for that in D, then you shall get this. Then also we know that R1 plus R2 is equal to A, and therefore D is going to be I1 plus I2 minus A. Now, applying the condition, we shall remember that I1 is equal to I2, which we can call I, and then R1 is equal to R2, which we can call R. So if we substitute, we shall have here I plus I, which is 2I, and then is minus A. So we shall have this, and then we make I the subject. We shall get D min plus A divided by 2. So we can use small letter here or capital letter. Also, A is equal to R1 plus R2, which is equal to R plus R, which gives you 2R. And therefore R is equal to A divided by 2. Now, just to go back a bit, applying Snell's law, we are going to apply Snell's law in one of the surface here, in order, because we are deriving this relation, we are going to apply Snell's law here, and applying Snell's law, we are moving from air to glass, so we shall apply Snell's law there, and we shall have N air sine I is equal to N G sine R. Remember, we have replaced the I1 with I, and then the R1 with R. Then we shall make N G the subject, but remember N air is 1, the refractive index of air is 1. Then we shall have this, and then substitute also for I and R. When you substitute for I and R, since we already have I as D min plus A divided by 2, and then R is equal to A divided by 2, so we shall have this. Now, substituting for this, we shall have 1 here, then we shall have N G as sine of D min plus A divided by 2 divided by A divided by, divided by sine of A divided by 2. Now there is a mix up here, but can maintain the small letter here. And then we shall have this as the relation. Also, if we are moving from maybe a liquid into the glass, it means that this air would be L, this A would be L, and therefore the formula would be Ng is equal to NL sine of D min plus A divided by 2 over sine of A divided by 2. So this is what we would have if you had a liquid, if you had immersed it in a liquid, the prism in a liquid. Let's look at this graph, a graph of deviation against the angle of incidence. Now we need to know that from experiments, when we plot the graph of minimum deviation against the angle of incidence, as the angle of incidence increases, the angle of deviation decreases until a point which we call the D min, or the minimum deviation, where as we increase the angle of incidence, the angle of deviation will also be increasing. So the graph will look like this. As we increase the angle of incidence, the angle of deviation will be decreasing until a certain point, which we call the minimum deviation, where if we further increase the angle of incidence, the angle of deviation will increase. So if you want to determine the angle of minimum deviation, we can just do an experiment and then plot a graph of D against I, and then we shall get the minimum point here, which will be the minimum deviation. We shall look at this later on. Let's look at some examples. Calculate the angle of incidence at minimum deviation for light passing through a prism of refracting angle 70 degrees and refractive index 1.65. So let us apply this formula because we want to get the angle of incidence. So let us apply this formula first of all to get the D mean, the minimum deviation, since we have this, and then A is 1. So if you apply that formula, we shall have our D mean as 72.33 degrees. Then after getting the minimum deviation, we know that I is equal to D mean plus A divided by 2. So we shall have our I as 72.33 plus 70 divided by 2, which gives us 71.17 degrees. Then also this question, an equilateral glass prism of refractive index 1.5 is completely immersed in a liquid of refractive index 1.3. If a ray of light passes symmetrically through the prism, calculate the angle of deviation of the ray and then the angle of incidence. So they want to get the angle of deviation. But remember, it is passing symmetrically and it is equilateral glass prism. So A is going to be 60 degrees. So A is 60 degrees. Now, since it is passing symmetrically, also we need to know that when it is passing symmetrically, then the angle of deviation is going to be a minimum deviation. So we shall be dealing with the minimum deviation. And we know the formula for minimum deviation is this. Remember, we are moving from a liquid. We are moving from a liquid, so you shall apply this other formula. So when you apply that formula, we have this as 1.5, this is 1.3, so we can get the D mean. A is 60. So the D mean can be got from that. We cross multiply there and then simplify and get our D mean as 10.47 degrees. That's the minimum deviation, which is the deviation of the ray. Then let us also get the angle of incidence. The angle of incidence, you can use the formula. I is equal to D mean plus A divided by 2, and therefore I is going to be 10.47 plus 60 divided by 2, which will give us 35.24 degrees. Number 3, a ray of light propagating at a liquid is incident on prisms, on a prism of refractive index 50 degrees, this is 50 degrees, and refractive index 1.6 at an angle of, this is supposed to be 30 degrees as shown, so it is here. If the ray passes symmetrically in the prism, find the refractive index of the liquid. So it is passing symmetrically, and I've given us the angle of incidence and then the refracting angle. Now, since I've given us the refracting angle, we can get the angle of refraction. Since we know that it's passing symmetrically, so R is equal to A divided by 2. R is equal to A divided by 2, which gives us 50 divided by 2, which is 25. So the R is going to be 25. The angle of refraction is going to be 25. So using the angle of refraction and then the angle of incidence that has been given as 30, and we have the refractive index here, we can get the refractive index of the liquid. That's one way. Or if not, you can use the other formula that we derived. So let us apply Snell's law at this point. If I apply Snell's law from this point, we are moving from a liquid, we shall have n liquid sine I is equal to n glass sine R. So we shall have, this is 1 point, this one we don't know, NL we don't know, but we have this one as I is 30, then G is 1.6, N G is 1.6, and then R is 25. So we shall have this, making NL the subject, we shall get NL as 1.35. So the refractive index of the liquid is going to be 1.35. There are other ways you can get that by using the formulas I said, and then we shall substitute. Remember, NG is known, we are looking for NL. D mean, we have the angle of incidence as 30. So we can get the D mean, because actually this is the angle of incidence, this one here. All of this. So this is 30, and then this is 25 this is 50 divided by 2, which is 25. And therefore we shall get our NL as 1.35. Let's look at number 4. A glass of refractive index 72 degrees and refractive angle, and refractive index 1.66, and it is immersed in a liquid of refractive index 1.33. Calculate the angle of incidence of ray of light if it passes symmetrically, and also want us to calculate the minimum deviation. Okay, so we want the angle of incidence and it's passing symmetrical. So if it's passing symmetrical, you know I1 is equal to I2 and it's equal to I, and R1 is equal to R2 is equal to I, which is equal to R. So we can know from there that if you have, this is the diagram, it is always good for you to draw that diagram because it helps you to interpret the question better. So now we have, this is 72, which is equal to this 72. So first of all, we need to know that R is equal to A divided by 2, which will give us 36 degrees, since the refracting angle is 72 degrees. And then we shall apply Snell's law at this point. You can apply Snell's law at M, since we know I1 is equal to I2, which is equal to I. So I is actually what we are looking for. We are looking for this I. So we shall replace this with I. And we shall replace that with I and apply Snell's law. And then we shall have N liquid sine I is equal to N glass sine R. NL is 1.33. NG is 1.66. And therefore we shall have that. And then make I the subject. And I is going to be 47.2 degrees. Then after, we also want the minimum deviation. You can use the formula. This formula here, we know this, we know that, and then we know we want the minimum deviation. We know A as 72, and here 72. So when you substitute, we shall have this, and then we shall work out this, get this answer here, and then divide by 1.33 and get the sine inverse of this. Make D mean the subject, and then we shall be in position to get D mean as 22.38 degrees. Or if you don't want to use that procedure, you can just use the formula. D mean is equal to 2I minus A. Remember, we have our I as this one here, which is 47.2 degrees, and so we can get our D mean still as 22.4 degrees. If you round off this, you'll get this. So this is the same. Yeah, thank you for your attention. We meet in the next lesson.